Welcome to Study Loop.
So we should first write the equation that describes these waves, and this is going to be y of xt is going to be 0.0275 meters. This is 2.75 centimeters. However, I just wanted to convert into meters immediately. So we'll have cosine, and then it'll be times cosine, and then this will be 0.410 radians per centimeter times x, and then plus 6.20 radians per second times t. So this will be our equation for the wave, and then we know that a standard equation for a wave is going to look like this: a cosine of k x minus omega t. And then we are asked, the question is asking us, how long will it take for a waveform, essentially, for a complete waveform to pass by the fisherman? And the time to complete one wave pattern is called the period. So we can say that omega is going to be equal to 2 pi over t, where t is the period. T is going to be the time for one complete wave pattern to pass the fisherman. We simply need to solve for t, and this is going to be 2 pi divided by 6.2 radians per second. We found the omega here by relating this equation to this equation, and this the coefficient of the t is going to line up with the omega, or the angular frequency of this wave. So the angular frequency of the wave is found simply by taking it from the original equation, and this is going to be equal to 1.013 seconds. Now, they're asking us to find the horizontal distance covered, so we can use the wave number. This is going to be 2 pi over lambda. And the horizontal distance covered in one complete wave pattern would be considered the wavelength of the wave. So it's convenient that we can just use the equation for the wave number, isolate the wavelength, and then we can plug in for our constants. K, we're getting it from the equation. It's going to be this variable right here. So 0.410 radians per centimeter. And then, of course, the wavelength is going to be 15.325 centimeters. Or we can say the wavelength is equal to 0.15325 meters. And then at this point, we can find the frequency. So part B is asking us to find the frequency. And again, the wave number is, well, rather B asks for the wave number. The wave number we can just say is 0.14 radians per centimeter. That's just taken from the equation. And then the second part of B is asking for the frequency. We know the frequency, we know the angular frequency is equal to 2 pi the frequency. So we can just say that the frequency is equal to the omega divided by 2 pi. This is going to be 6.2 radians per second. And then it'll be over 2 pi radians. And we have that the frequency is going to be equal to 0.987 hertz. At this point, we can say that the C, they're asking us for the speed of the waves moving past the fisherman. So we can say that the speed of propagation is equal to the product of the wavelength and the frequency. We know both of these equations. We know both of these. We know both of these variables, and we can say that this is going to be equal to 0.15325 times the frequency of 0.987, and this is going to be equal to 0.1513 meters per second. So that'll be that. That'll be the speed of the wave moving past the fisherman. And again, this is our wavelength converted into meters, and then this is our frequency that we found in the previous part. And then they're asking us for the max velocity of the bobber going up and down. So here it would simply be the angular frequency times the amplitude. This is found by these are periodic waves, so we can use this equation to find the speed of the bobber, but the speed of the bobber is not the speed of the wave. This is why we have obviously a different equation. The speed of the bobber is actually the velocity in the y direction, so it would be defined as like a point, essentially, on a point on the wave. So here it would be the maximum velocity would be the amplitude times the angular frequency. At this point, we just need to do 6.2 radians per second times amplitude, which would be 0.0275 meters. And this is going to give us a maximum velocity of 0.1705 meters per second. So this would be speed of bobber, max speed of bobber. And that'll be the end of the solution. Thank you for watching.